Hello guys, welcome back to my YouTube channel. So question set 43. So this is the last video about relational algebra queries. So let's go to our video and see what kind of questions on there. So question set 43. There are 5 engineers who develop the database of the software company. You are one of those 5 engineers. The company you work for has been assigned to create the software, and you have entrusted the team to create a database of that software. The software uses the product brand table to store product information in the database. Use this table to answer the following questions. So now that sound called, we have product table and brand table also, like in our previous video. So let's take this out. Yeah, we have a product table. So there are 9 products here. Yeah, those are biscuit products. Crisco, cheese bits, snacker, spicy, gift assortment, like, okay. I know whatever. Potato crackers, they are potato crackers. Those are delicious. So brand ID. We have 3 more brands here, I think. Let's see. Yeah, 3 brands here: Maliban, Munchie, and Sunrich. So let's find out what is the first question. So create the relation algebra query needed to find the Choc Shock biscuit on the product table of the database. Let's go to previous table, and Choc Shock product ID is 5, brand ID is 2. Yeah. Going to next one, and that is Munchie, Munchie biscuit. Yeah. So now we need to write the relation algebra query. First, I get this sigma mark, and now I need to get the exact brand. So my brand is Munchie because Choc Shock brand is Munchie. So we need to get the product name equal to Choc Shock because this is the product name. So we can get those things from our product table. So this is the relation table, and this is the proportional logic formula. You can understand, you can remember that thing if you watch my 39th video. 39th video is all about selection operator in relation algebra queries. So this is the selection operator of relation algebra queries. So when we put that sigma mark, we want to use this proportional logic formula. So logic formula is also a product name equals to Choc Shock. So we have to find this Choc Shock brand, Choc Shock product and product name. So product name is equal to Choc Shock, and relation table is product table. So you can see it. And we are going to second question. So search for product detail under the brand name Hawaiian cookies. So I'm just repeat like Huawei, like a previous video. So Hawaiian cookies and product Munchie. So we have to find this brand and also this product, Hawaiian cookies product. Create the required relation algebra query. So we have some condition here. Use 2 as a brand ID. So Munchie brand is 2. So that is a kind of professional logic formula. So use this sigma mark, and now we have to get 2 conditions. So we have product name, and we have exact product brand. So now we want to get the product name equal to Hawaiian cookies. So that is one condition, and we have another condition. So we want to connect the condition using AND operator. So get the AND operator, and now we have to use 2 as a brand ID. So that is the condition. So our logic formula is brand ID equals to 2. So now we can get this logic formula from this relation table, product table. So this is the relation algebra query for that question. So we have 2 conditions. We have exact product name to find. So we find it, and we have exact we have exact Munchie. We have exact brand to find. So we find it using this formula. And this is the relation table. We got this all details from this table. So that is the meaning of this query. Let's go to third question. So SQL query is designed by other members of your team. So we are making relational algebra query. They made some SQL queries. So SQL query means DML queries. So write the relation algebra query to find create the query. So we have to write the relation algebra query for SQL query. So that is interesting, kind of interesting. So let's see what is the SQL query they wrote. So this is the SQL query. Select product name from product and select product name from product where brand ID equals to. So now we want to create the relational algebra query for those two SQL queries. So let's do that, and I get this SQL query quickly for here. And now I need to write the relational algebra query for first one. So let's get the projection operator. So this is not a theta. This mark is not a theta. This is phi. So Greek letter that called phi. So in my previous video, I at once I think I told you this symbol is theta, so it is wrong. So this is phi. So we can call this mark to phi. And we get this projection operator, whatever it is, phi or theta. This is projection operator in database language. So I get that projection operator on here, and now I can get this attribute name. So my attribute name is product name. So I want to search product name. So I get the product name attribute, and now I need to get product name from product table. So my relation table is product table. So I get the product table on there. So this is the first query, first relation query for this first SQL query. So I will connect that on here like that. Yeah. All right. So second one, let's go to second one. So select product name from product where brand ID equal to. So we have where clause here. So where clause means we have to use sigma mark. That means selection operator. So first we can use projection operator to project that attribute name. Attribute name means product name attribute. And now we want to find the exact brand ID. So brand ID equals to 2 means brand ID is Manchi. So we have a logic formula here. So now we can't use Manchi keyword. We can only use brand ID. So I will use a sigma mark for find that brand ID. So let's go to projection operator and get the product name from product table. But now I don't get it in product table. I have exact brand here. So I'm giving this open bracket and closing bracket. And now I have selection operator selection operator related relation algebra query inside these two brackets. So let's get the sigma mark on here, and brand ID equals to 2. Yeah, I need to change that. Now I change that. I just mistake it. So brand ID equals to, so you can see we get that condition, and now we can get these things from our product table. Okay. Now this is the complete query. So I will explain you once again. So projection operator, because we need to project this attribute name. So we project the attribute name using this phi mark or projection operator. You can use those two words for this symbol. And we are projecting this product name attribute from product table, but we have exact brand ID to find. So when we have to exact brand ID to find, so we are using sigma mark, that means selection operator. So selection operator and get these two brackets and get the professional logic formula. And now we can find those details from product table. So that is the relation algebra query for that second SQL query. So I will make that kind of a square for that and join it on there. And now you can clearly understand what is the first relation algebra query for first SQL query and second one also on there. And now it's all right. We already did 5 more question set about relation algebra query. Now you know what is the history about our database language. So we are learning this DML and DDL language because of this relation algebra query. So you must learn about this relation algebra query, but you don't need to use, and you can't use this in your industrial uses. So this is the final part of this relation algebra query. So in my next video, I will do some DDL queries, and we have another 6 more questions set to do, and my series is over. So yeah, in my next video. So I will catch you guys in my next video. Peace.